All right, so in this video, we're going to talk about something information that you can get out of like double layer capacitance of your electrodes. And what that is information about the effective length of the electrodes. And so this comes from one of the equations of capacitance, which says that the capacitance is equal to the dielectric constant, dielectric medium of the capacitor times the area of the plate of the capacitor over the distance that the plates are from one another. Or we can put L as length is another way of thinking about it, right? So how this works is that in an electrode, let's say you have it negatively polarized, we know that positively charged ions are going to associate there, and then negatively charged ions on top of that, and so forth in this double layer structure. This has some capacity associated with it, okay? And so what happens if you have a modified electrode? Let's say this is gold, a gold electrode. Very common thing to do with gold is to make self-assembled monolayers out of alkyl thiols, right, of a certain length. And so if you have these alkyl thiols on the electrode, and then you do the same sort of capacity type measurement, your capacitance is going to go down. And that's predicted by this equation. You have the same area of the electrode, assuming you just did these experiments before and after modification, and your L went up, so your capacitance went down. So in your CV, you should expect your double layer capacity, let's say we're doing this in the absence of any redox potential, would start from something like that, black line, and then go down to something lower in the red line. Our capacitance went down. Now you can actually use this to try to estimate the length of your linker. You do know the area of your electrode, and the dielectric media you could maybe estimate using similarly, structured molecules with similar chemical structures. Um, for alkanes, for example, you could use some dielectric media. But this is sort of approximation because you don't really know what the dielectric media, effective dielectric media is of the whole structure, right? And so this can be sort of hit or miss, but what definitely you can use this sort of relationship as is a qualitative way to show that, yes, indeed, I did successfully put an overlayer onto my electrode. The self-assembled monolayer here is just an example. Could be many other different types of overlayers that are going to increase your effective length of your electrode and therefore separate out the charge of your parallel plate capacitor here that you're making in the double layer electrochemically, and thus reducing your capacitance.